Dozens of scientists tried but failed. A puzzle built to challenge the human mind, so complex that even advanced AI couldn't solve it. It was meant to test logic, emotion, and memory all at once, a riddle no human cracked. But one day, a dog walked in, and in less than 10 minutes, did something no one believed possible. What he did next left an entire laboratory in silence, and changed the way science understands intelligence forever. Don't forget to like and subscribe. It started in a quiet behavioral lab inside a California university, glass walls, humming machines, and the soft flicker of white light over polished metal. For months, a team of American scientists had been studying how emotion connects to decision-making. They designed a device called the cognitive resonance box, a transparent cube with multiple layers of puzzles, lights, and tones. The goal was simple: press the right combinations to unlock the final door. The process, however, was impossibly complex. It required emotional anticipation, not just logic. Every human test subject failed. Every AI simulation collapsed under unpredictable sound patterns. The researchers called it unsolvable, until one morning an intern named Lena arrived with a golden retriever named Max. Max wasn't part of the experiment. He was just a rescue companion, calm, loyal, and endlessly observant. But when he entered the lab, something about him drew attention. His eyes scanned everything: the glowing cube, the sound panels, the reflection of scientists behind glass. It was as if he understood the tension in the air. Dr. Sanders, the head of the project, smiled politely. "He's cute," he said, "but this puzzle breaks grad students, not pets." Lena chuckled softly. "Maybe, but sometimes intuition beats logic." They agreed to let Max try, half as a joke, half out of curiosity. The cameras rolled, sensors blinked, and the cube powered on. A synthetic voice echoed through the room. "Begin sequence." Max approached the device. The first panel flashed blue. He pressed it with his paw. A chime. Then he pressed red, a harsh buzz. The system reset. A few scientists chuckled quietly. "Well, that's that," one murmured. But Max didn't stop. He stared at the cube, ears twitching at every tone. His head tilted slightly, the universal sign of a dog trying to understand. He waited. The hum of the machine changed pitch, and his eyes followed the rhythm. This time he pressed blue again, then green. Chime. Yellow. Another chime. The first lock opened. Every scientist froze. The soft whir of the lab machines was the only sound left. Someone whispered, "He got the pattern." They reset the sequence. Max repeated it flawlessly. Then again. He wasn't guessing, he was listening. His movements were deliberate, his pauses precise. Dr. Sanders leaned forward, disbelief mixing with awe. "He's not reacting, he's predicting." The next level activated, a mirrored set of lights, changing in sync with sound frequencies. For humans, it had taken hours just to identify the correlation. Max watched the cube for nearly a full minute, then circled around it, studying the reflection on the glass table. He pressed his nose gently against a mirrored light, and the second lock opened. "Run it again," Sanders ordered. They did. Max solved it again, then again. Within minutes, he reached the final stage. This part wasn't about patterns anymore. It required an understanding of time and coordination. A faint melody played, 3 rising tones, 1 descending. The cube waited for an input based on rhythm. Humans had tried tapping in sync but failed every time. Max stood still. His ears perked up as the sound began. He raised his paw slowly, then tapped the panel exactly in rhythm, matching the sound perfectly. The cube glowed white. A soft click echoed through the lab. The door slid open and the treat fell out. No one moved. Lena gasped and covered her mouth. One scientist dropped his pen. Another whispered, "This isn't possible." Dr. Sanders finally spoke, voice trembling with excitement. He didn't just respond, he understood. For the first time, A dog had solved a multi-step puzzle that had defeated every human and computer tested before it. Max had combined sound, memory, and timing, the same processes that define emotional reasoning in humans. The team decided to repeat the test 10 times. Max solved it every single time. But what came next shocked them even more. In a follow-up session, researchers tried a cooperative version of the puzzle, two levers placed far apart, both needing to be pressed simultaneously to unlock the reward. Humans required communication to coordinate it. No animal had succeeded before. This time, Max wasn't alone. A border collie named Luna joined the session. They were released into the room together. The scientists waited, expecting confusion. Max walked straight to one lever and barked once short and sharp. Luna turned her head toward him. Max barked again, then pressed his side. Luna mirrored him. Both levers clicked, the box opened. Gasps filled the observation room. It wasn't luck, it wasn't training. Max had communicated a plan. That night, Lena sat beside him outside the lab under the California sunset. The sky glowed orange and Max rested his head on her knee. "You know," she whispered, "they thought you were just a dog, but you're showing them what heart looks like when it thinks." Over the next few months, the team ran dozens of tests. Each time, Max's brain activity amazed them. Using MRI scans, they found that during problem solving, his brain's prefrontal regions, the same areas responsible for planning and emotional intelligence in humans, lit up intensely. He wasn't just acting on instinct. He was connecting feeling with logic. The scientists began calling it empathetic reasoning. For decades, researchers believed emotion clouded intelligence. Max proved the opposite, that empathy could enhance understanding. News spread quickly. Headlines across journals read, "Golden Retriever outsmarts scientists in cognitive puzzle." "Dog displays human-like problem solving." Proof that emotion is a form of intelligence. But fame meant nothing to Max. He never knew he'd made history. All he cared about was the joy in Lena's voice when she said, "Good boy." After 2 years of studies, Max was retired from experiments. His data changed animal cognition forever. He returned to a quiet life, long walks, open parks, soft evenings. But to those who knew him, he wasn't just a pet anymore. He was proof that brilliance can exist in silence and that love can think. Dr. Sanders kept a framed photo of Max on his desk. Whenever students asked why a dog's picture sat beside years of research papers, he'd smile and say, "Because that dog reminded us what intelligence really means." One summer afternoon, Lena visited the lab for the last time. As she walked down the hallway, memories of that glowing cube echoed in her mind, the beeps, the hums, the soft click that changed everything. Outside, Max sat waiting, tail wagging in the sunlight. Before leaving, she turned back one last time, whispering, "You solved more than a puzzle, Max. You solved us." He barked once softly, as if he understood. And then they walked away together, leaving behind a legacy written not in equations, but in empathy. Because sometimes, the smartest mind in the room doesn't speak a word. Sometimes it simply wags its tail. Don't forget to like and subscribe.